Now coming to the questions part. First question. It is based on NCERT questions, in-text questions. The question is, an object is placed at 10 centimeters first and second 5 centimeters in front of a concave mirror. Of radius of curvature is 15 centimeter. Find the position, nature and the magnification of the image in each case. So let us try to solve this problem. Before solving, first make the ray diagram of. So basically it is a concave mirror. It is given in the question. So making a concave mirror here of radius of curvature is 15 centimeter. So if the radius of curvature is 15 centimeter, then the focal length is coming out r by 2, which is equal to 15 by 2, that equal to 7.5 centimeter. Which means that the radius of the focal length of this concave mirror is 7.5 centimeter. Let us put focal length at this position and center of radius of curvature at this position. So it is given that the radius of curvature is 15 centimeter. So it is 15 centimeter from the pole and this is 7.5 centimeter from the pole. My first part of this question is when object distance u is given as 10 centimeter. Using a proper sign convention, which is given as minus of 10 centimeter, because object is in between C and F. Object distance is 10 centimeter, which is lies between C and F. Let's say like in between at this point, and AB is the height of an object. So for making a ray diagram of this is parallel to the principal axis and passes through the focus. And from this point it passes through the focus and then move on this point, which is coming at this point somewhere. It is denoted as A dash B dash. And the height is H dash, height of image, and the height of object is H. So V is equal to 10 into 7.5 by minus of 2.5, which is equal to minus of 30 centimeter. So here we come the minus of 30 centimeter. The object distance. Negative sign shows the nature of the image formed, that is left side of the concave mirror. Now we calculate the magnification of this. Magnification, as we already discussed about, magnification M is equal to H dash by H, which is equal to minus V by U. So it is coming out minus of 30 by minus of 10. U, we know that it is 10 centimeter, and negative sign shows the sign convention because the object is 10 centimeter from the pole, that is another side, the negative side of concave mirror, and minus 30 we already find out the image distance of object, which is 10 centimeter from the pole, is minus 30 centimeter. So by calculating we can get that minus 3 as a magnification. So we calculated the magnification of this object. Now we have to find the nature. We find out the position, we found out the magnification. We want to find out the nature. Nature of this image formed is real, inverted, and magnified. Here draw the diagram. I draw the diagram of refraction. When an incident ray is strike on a surface, some part is reflected back and some is refracted. So refraction is the phenomena in which when the ray of light is passing from rarer medium to denser medium, some part of light is reflected back and some part enters as a reflected ray. So, stop. Start. So the definition is when the light enters from rarer medium to denser medium, some part of light are reflected in the same medium and some part of light are refracted into second medium. So here is the definition of refraction. So according to this definition, we see that when an incident ray fall and it reflected and refracted, both phenomena happen. Then the refracted rays, when a light enters from a strike on the surface and refracted, this phenomenon is called as refraction. Stop. Start. Now comes to law of refraction. First, it is stated that the incident ray, refracted ray, and normal at the point of incidence all lies in the same plane. The incident ray, the reflected ray, the refracted ray, and the normal all lie in the same plane. At point of incidence, all lie. This is the point of incidence. This is the point of incidence. All lie at the same plane. Incident ray, refracted ray, and the normal, the point of incidence. At the point of incidence, all lies in the same plane. Second law of refraction says that the sine of angle of incidence, sine of angle of incidence to the sine of angle of refraction is constant. By mathematically, we say that sine of I by sine of R is equal to constant, and this is proposed by Snell's laws of refraction. Now let us have a look in the different parts in refractions. Refraction through glass slab. how the refraction is taking place in glass slab. Here we take a glass slab of thickness T, name it as A, B, C and D, and here we draw the normal to this glass slab. When an incident ray is falling at this glass slab, this is incident ray. It reflected and refracted to this part, and at this stage as well the refraction takes place and it goes like that. So here is the angle of incidence, here is the angle of refraction, here again angle of incidence, here angle of refraction, here angle of reflection. This is the reflected ray, this is refracted ray. The air is considered as rarer medium, and inside the glass slab it is considered as denser medium. And the refractive index of air is denoted as mu of A, and refractive index of glass slab is denoted as mu of G. So here is that the refraction through glass slab. If we taking this incident ray and we extend it to at this point, it is parallel to the refracted ray which is coming out through the slab, and this is called lateral shift. So refraction through parallel slab is sine of I1 by sine of R1 is equal to sine of I2 by sine of R2 by Snell's law of refraction. Law of refraction. We already illustrate that sine of angle of incidence by sine of angle of refraction is equal to constant. So again we write through this is mu of A with respect to B into mu of B with respect to A is equal to 1. Again this is air, so it is mu of A. So here I1 is not equal to R1 and I2 is not equal to R2. So important point to be remember. First, in refraction, frequency and phase of light is constant, that is, do not change. And second, in refraction, velocity and the wavelength of light may change. So these important 2 points. In refractions, frequency and phase of light do not change, and in refraction, velocity and wavelength may be changed according to suitable conditions. Stop. Here we discuss the apparent depth and real depth. We already studied about the refraction, so here the case in which a tank which is filled with water, an object is lying at the bottom of this tank. When a ray of light is incident at this, it refracted and goes through this medium. Because the tank is full of water, it's refracted and the image is formed at somewhere at this position. So this is the real height of the object and this is the apparent height of object where the image is finally formed. So this is the rare medium and this is denser medium. Rare medium is denoted as mu of A and denser medium is denoted as mu of B. So in first situation we see that when light travels from O to A, when light travels from O to A, sine of I by sine of R is equal to mu AB. Here it means mu of AB is equal to refractive index of B with respect to A. And when we write mu of B of A, it means refractive index of A with respect to B. So B with respect to A is written as sine of R by sine of I. Here HR by HA, where HR is denoted H, where HR is the real depth of object and HA is the apparent depth. That is equal to start. That is equal to mu of A B. That is all equal to real depth by apparent depth. Now we see the apparent shift. In this diagram, the apparent shift when the object is moved from this position due to refraction, then this part is the apparent shift. This part is apparent shift. So apparent shift we may write as HR, that is the real height minus the apparent height. And we know that HA is equal to HR by mu. As we see in the picture, HA, that is the apparent height, is equal to HR, that is the real height, into the denser medium refractive index divided by denser medium refractive index. So HA, now the apparent shift of an object due to refraction is equal to HR minus HR by mu, which is equal to HR, which is taking as common 1 minus 1 by mu. This is the final apparent shift. Stop. Start. Here we take some example of this. When an object is in stop. Start. When an object is in denser medium, and the observer in the rarer medium, then HA is less than HR. Stop. Start. For example, if a bird is flying over a pond, suppose let us consider this as a pond. If a bird is flying here and they see the fish inside the pond, there is a fish inside the pond at this position, it means that, stop. Start. For this position, when a bird is fly here and fish is inside the pond, the bird thinks that the fish is not at this position, it may be lie in this position. Means there is a shift due to refraction of light when it sees from rarer medium into the denser medium. Here it shows that the bird sees the fish above the sea level, right? Above the sea level, in which they are not at an actual depth. It means not at the actual depth. The actual depth, the actual height of this fish means HR, so it may be occurs at HA. The bird thinks that it may occur at HA, that is the apparent height. Second case, if the object is in rarer medium and the observer is in denser medium, then HA, that is the apparent height, is greater than the real height. Stop. Start. Thus, to a fish, if we are seeing from the fish eyes, then the distance of the bird is farther as this actual height. The application of total internal reflections, in which I draw two diagrams related to this. This is a normal condition when observer is moving in an uniform temperatures day, in which like 25 degrees centigrade at atmosphere temperatures, the object which is lying distant from the observer is clearly visible and the refractive index at this is constant. Whereas for the total internal reflection, in which a application called mirage is coming, when a hot dry summer day, in which when an observer is moving and the object is some distance from the observer, the way in which the temperature is greater than 40 degrees centigrade outside, the refractive index decreases. Refractive index, that is mu, decreases here, and the observer thinks the object is really very close to their eyes. So here comes the application of mirage. Another application of total internal reflection may be considered a diamond. Suppose this is the shape of a diamond. When a ray of light is traveling from rarer medium to denser medium, suppose the ray A is traveling from denser medium to rarer medium, it follows the law of reflection and it's bended back in this direction. Here the surface strike and the law of reflection takes place and it gives a total internal reflection. Start. So here we go, the light is traveling from rarer medium to denser medium. This is the rarer medium. And inside it, diamond, it is a denser medium. Light strike and came back in the rarer medium. Suppose this light is also another light B is traveling from this direction and also follow the law of reflection in two surfaces and come back as B dash. So this would be the case of diamond, in which the light travels from rare medium to denser medium. Suppose it is A dash, A double dash, B double dash, and C double dash. The shape of triangle is in form of diamond. So it's finally we can see that due to total internal reflections, suppose this angle is 45, this angle is 45, this angle is 90 degree.